Hi everyone, and welcome to a small side video where I'm going to show you how to put an ILA into a Zynq device example. So an ILA is really useful when you want to see what the signals are doing inside the FPGA. So maybe your simulation works, but your synthesis doesn't. And when you put it in hardware, it doesn't work. I'm currently busy testing the next video in the series, and I'm putting in an ILA in this to check why it's not working at the moment. So we start by and in ILA is internal logic analyzer. We start by going IP catalog, we search for ILA. There's two here. This one, the system ILA, is for the block diagram for an AXI bus. So if you want to put an ILA on an AXI bus, you can use that. I'm going to be using this one here, which is the one that you put in your code. I'm choosing native because I am not probing an AXI interface and I want 4 probes. That basically just means 4 signals. So then if we look here, you can see it's giving me 4 ports, and these 2 are going to be 32 and then those 2 are going to be 1. And now that's my ILA. Basically what this does is it allows me to see these signals specifically inside the FPGA during the hardware running. So this gets built into the bit stream, and I will show you how we view it. So we go, okay, and now it creates it, and it's creating all of the bits that we need. Done. Now I head over to IP sources, expand it, instantiation template, copy this, and paste it into my code. I'm going to make this ILA_I. I'm going to put address there. So I'm basically just going to populate these values, these signals, with my signals that I'm interested in, and I'm just going to run bitstream, generate bitstream. Yes. So this way I can debug my FPGA during runtime. So now it's built, bitstream is done. Now I need to export the XSA file just like I usually do, because it's a new bitstream, which means it's a new XSA file. So file, export hardware, next, include bitstream, next, yes, finish. So now it's making me a new XSA file with this new bitstream. Okay, now we launch Vitis. Tools, launch Vitis. Okay, we've got Vitis. I'm going to right click here and go update hardware specification. And this is going to allow me to choose the XSA file again. So that's that one. And then it's going to say out of date here because it's a new XSA file. So it says updated hardware platform specification. And now this says out of date. So I'm going to choose this one to build. And when I build this, it's going to build the entire stack for me, including this Zynq example wrapper, which is going to become not out of date anymore. So now the build will take longer because it's building everything. You see how that's not out of date anymore? And then it's going to build the ELF file again. So there we go. So now we've got the build done. So now we program. Let me just plug my FPGA in. It is in, it just needs to be on. Okay. I'm going to program. So all of this is exactly the same as one would usually. There we go. So now it's running. We go back to Vivado and we go open target at the bottom here. Open new target. So we're opening the target here, which means we are looking at the FPGA while it's running over JTAG. Next, finish. In Vivado, it has immediately picked up that there's this ILA, and it's picked up my signals that I put into the ILA. So now what I'm going to do is I've got to choose a trigger. I've got to choose what signal to trigger on. So I'm going to push this button and choose sequence valid. Actually, get next number, I think, is equal to a 0 to 1 transition. So I want to see the rising edge of get next number, and then I hit go. So the way that this works is there's a RAM buffer in the FPGA live now. And when I set up the trigger and I trigger on a specific signal, when that condition occurs, so in this case it's get next number goes high, the values for those clock cycles are saved into the RAM buffer in the hardware, and then they are offloaded over JTAG to my PC. And so this way I can see the values of the signals on the FPGA, and that's what this is doing. So I just thought that I would make this video. Oh, another thing, if it's not a Zynq, say for example it's a Vertex or a Kintex or another board that doesn't have a PS, it doesn't have a CPU component, this process is exactly the same, you just don't use Vitis. You just program the device here from inside Vivado and then immediately go into the ILA analyzer. And that's it. You skip the Vitis step. The Zynq is the more complicated case because you have to go into Vitis, programming in Vitis, boot it in Vitis, and then go back to Vivado and open the target. If it's not a Zynq, if it's just like a Kintex or a Vertex, it's easier because you just program the target in Vivado and then immediately go into the ILA in Vivado. Much easier. So thanks for watching. I'll see you in my next video. Bye!